So for the next section in 4.6, we're going to be still looking at derivatives, but we're now looking at another application, which is called our rectilinear motion, getting into our velocity, acceleration, and speed. So when we talk about rectilinear motion, we're looking at a particle that can either move in either direction along a coordinate line. This line may be your x or y axis, or it may be another line inclined at some angle. In general, we refer to this coordinate line as the s-axis. We talk about a position function. Since we're referring to the general coordinate line as the s-axis, we're referring to this position function s of t. And this is just simply the coordinate of the particle at a particular time. So think of your s of t as an f of x if you're relating it back to the algebraic functions we've been studying. So let's take a look at this particular graph. So again, just like we were doing when we were studying our graphs with f of x, f prime of t, and f double prime of t, always pay attention to what graph they are giving you. So for example 1, they're showing you a position versus time graph for a particle moving along the s-axis. Describe in words how the position of the particle is changing in time. So let's take a look at time 0. So at s of 0, the position of the particle is -3. So at t is equal to 0, the position is -3, because that's the y-intercept on this particular graph. So if you notice, as your particle is traveling from a time of t is equal to 0 to 4, the particle is moving in the positive direction. So from s of 0 to s of 4, the particle is moving in a positive direction. And how I know that is because if you notice, the curve is increasing. But notice when we move from s of 4 to about, let's just call that s of 6.5. The particle is moving in the negative directions. And how I know that is because notice the curve from t is equal to 4 to t is equal to 6.5 is decreasing. And then notice from about 6.5 to 10, it's a constant, which when you're interpreting this means the particle has stopped. So from s of 6.5 to s of 10, it's a constant, which means the particle has stopped. So we're talking about the position curve given to you, and you want to know how the position is changing over time. This is how you can read your s of t graph. So we talk about velocity. It describes how fast and in what direction the particle is moving. So your velocity function is the first derivative of your position function. So v of t is your s prime of t. So s of t is your position function, s prime of t is the velocity. The sign of velocity will tell you which way the particle is moving. There's 3 possibilities. V of t is greater than 0, which means your s is increasing with time, so the particle is moving in the positive direction. And again, we saw that when we examined the graph of s of t, you can tell the slope of your tangent lines were all positive from that 0 to 4. V of t may be less than 0, which means s is decreasing with time, so the particle is moving in the negative direction. And again, we saw that when we were examining our position curve from 4 to 6.5. The slope of all my tangent lines were negative. Or v of t, which is equal to 0, which means s has momentarily stopped. And that's where on our position curve it was constant. We had a slope of 0. So those are 3 things that could happen with our velocity signs. Remember, when we talk about v of t, it's what we call the instantaneous velocity. And again, this is to distinguish it from average velocity. A lot of times that instantaneous word is omitted and just velocity is used. So again, when velocity is understood to mean instantaneous. Velocity. Speed describes how fast the particle is moving. The speed function is the absolute value of the velocity function, or the absolute value of the first derivative of the position function. Speed is always non-negative. It tells you how fast the particle is moving, but it does not tell you anything about the direction. And we talk about acceleration. It's the rate at which the velocity of the particle changes with time. And the acceleration function is the derivative of the velocity function. Or another way to look at acceleration is your second derivative of the position function. So velocity is the first derivative of the position, acceleration is the second derivative. So just to give you some practice here, I'm giving you a position function s of t, and they're telling you that t is greater than or equal to 0, and this is the position function. And they're telling you that s is measured in meters and t is in seconds. They want you to find the velocity, speed, and acceleration functions. So again, velocity, remember, is just the first derivative. Speed is the absolute value of the first derivative. Acceleration is the second derivative. And then they want to evaluate part B, those three functions at t is equal to 1, and then they want you to graph each one. So for part A, to find my velocity function, I'm going to find the derivative of my position function. So then this will be 4t minus 8. So my speed is equal to the absolute value of the velocity function, which is just going to be the absolute value of 4t minus 8. And then my acceleration is the second derivative of the position function. So that's going to give me just 4. So now for part B, they want me to find the velocity, speed, and acceleration at t is equal to 1. So v of 1 is going to be equal to 4 times 1 minus 8, which is negative 4, and again my units is going to be meters per second. The speed, which is equal to the absolute value of the velocity function, is going to be the absolute value of 4 times 1 minus 8. So that's going to give me 4 meters per second. And then my acceleration, since that's a constant, is still going to be 4. And that's going to be meters per second squared. And then they want you to graph the position, velocity, speed, and acceleration functions. So s of t, my position function, which is my original. Again, I'm going to go ahead and factor out a 2t, which will give me a t minus 4. So I know that I have an x-intercept at 0 and at 4. It's a quadratic that's opening up. Now remember, t has to be greater than or equal to 0. So I want to have my starting point going to be right here at 0. So there's my position function. My velocity function, which remember is just the first derivative of the position function, I found to be 4t minus 8, which is a linear function, y-intercept of negative 8, slope of 4. Then my speed, which is the absolute value of the velocity function. So the way you can sketch the absolute value of the velocity function, remember, when you're taking the absolute value, all of your outputs, which are your y values, have to be positive. So after you graph your velocity function, this region is simply going to be reflected above the x-axis. So right here on my velocity function, I know I have an x-intercept where y is equal to 0. So when I set 4t minus 8 equal to 0, I know this x-intercept is at x equals 2. So that represents this positive part of the velocity graph. So right here then, I need to take this part of the graph and just simply reflect it above the x-axis. So this point that's down here at 0, -8 is going to be up here at 0, 8. So when you're trying to graph your speed function, after you graph the velocity, you simply take that region of the graph that is below the x-axis and you're going to reflect it, because remember, with absolute value, all of your outputs will be positive. And then the acceleration function is just your constant before. So that's what the graph of your position, velocity, speed, and acceleration graphs are going to look like. So one last thing, when we're talking about speed, we're going to talk about speeding up and slowing down. If a particle is moving in a positive direction, then the particle is speeding up. If the speed is increasing and slowing down, if the speed is decreasing. This is not the case if the particle is moving in a negative direction. So here I'm giving you two curves. I'm giving you the velocity curve in relationship to speed. So here's my velocity curve. So the way you determine whether or not a particle is speeding up or slowing down, you want to look at the velocity in relation to the acceleration. If the velocity and acceleration have the same sign, then you know your speed is increasing. If the velocity and acceleration have different signs, then the speed is going to be decreasing. So let's take a look at this particular velocity curve. So from my interval 0 to a, notice my velocity is decreasing, or my acceleration is decreasing. So because v of t is below the x-axis, I know that my velocity is negative, because remember, this is my velocity curve. Now my acceleration, because my velocity is decreasing, I know the slope of all these tangent lines are negative. So both my velocity and acceleration are negative. So therefore, I know that my speed has to be increasing. If you look from my interval from A to B, notice the velocity curve is still negative. It's still below the x-axis. So my velocity is still negative. However, notice that the velocity is increasing from A to B, which tells me that the slope of all these tangent lines are positive from A to B. Therefore, my acceleration is positive. So since velocity is negative, acceleration is positive, they are working against each other. So therefore, my speed is going to be decreasing. Notice from B to C, my velocity curve is above the x-axis, so I know my velocity is positive. My acceleration, notice the velocity curve is still increasing, so the slope of all those tangent lines are positive. So my acceleration is positive. So therefore, I know my speed is increasing, since velocity and acceleration are both positive. From my interval C to D, notice that velocity is still positive. However, notice that my velocity curve is decreasing. So therefore, I know my acceleration is negative. So therefore, I know my speed is decreasing. From D to E, my velocity curve is below the x-axis, so my velocity is all negative. Notice my velocity curve is still decreasing, so the slope of all these tangent lines are still negative. So my acceleration is negative. So since velocity and acceleration have the same sign, I know my speed is increasing. And then finally, from E to F, notice Velocity is still negative. However, notice my velocity curve is increasing, which means the slope of all these tangent lines are positive. So since velocity is negative, acceleration is positive, I know my speed is decreasing.